Hey everybody, I'm Mr. Hartzler, and I want to talk to you today about logarithms. They're not terribly complicated, but for some reason they tend to trick up a lot of students. So kind of go through this slowly and do a lot of practice problems. And if you have questions, please ask them. If you're one of my students, always ask in class or shoot me an email. If you aren't one of my students but want maybe more information or clarification on something, then please write that down in the comments below. We start off by looking at what a logarithm is, and it's represented by just log, and we have base b of x, and we're going to say equals y. So log base b of x equals y, and that is true if and only if b raised to the y equals x. So that if and only if means it works both directions. It works from the log here and then from b up to the log. And really these are just two different ways of writing the same thing. We have logarithmic form and exponential form. Down here I showed the little bit of a looping mechanism. It's really just how we remember it. So base b, if we start there and we loop around, b raised to the y power equals x. And if you notice, that is what we have going on up here. Another way of reading log is what exponent on b will get me x. What exponent on b gets me x? Well, that answer is y. Okay, let's start working through some examples, and I think things will clarify themselves as we go. So we're starting off here, and we have log base 4 of 16 equals 2. We're going to start by just going into exponential form from log form. So we do that little looping technique around. So that's 4 raised to the second power equals 16. Check with yourself real quick, and is that true? Yes, it is. 4 squared is 16, and 16 does in fact equal 16. Good. Next one, log base 3 of 729 equals 6. Well, let's change that form. So what exponent on 3 gets me 729? Well, what exponent on 3 gets me 729? That's 6, or 3 to the 6th equals 729. Just going from log form to exponential form. Now let's go the other direction. Let's start off in exponential form and go into logarithmic form. So I'm going to need a log. I'm going to need an equal sign. What is the base up here? That's going to become the base of my log. Base is 4. So log base 4 of what? Well, what exponent on 4? Well, the exponent on 4 is 3. What exponent on 4 gets me 64? And we can always loop to check ourselves, because again, that's kind of the easier way, is going from log form to exponential form. 4 raised to the third equals 64. Yep, that's what we originally had. Over here we have log, what's our base? This one's kind of weird, but this one's 125. What exponent on 125 gets me 5? Well, that's 1/3. 125 to the 1/3 equals 5. What exponent on 125 gets me 5? That's a great way of trying to talk to yourself and work through that in your head. Last page here, we are going to evaluate or solve for these logs. What exponent on 3 gets you 81? Well, I'm going to start off by throwing in an equal sign and an x. Going from log form to exponential form, 3 to the x equals 81. Well, we've done this before, and we've always had these as the same base. So let's do that again. 3 to the x equals, well, this is 3 to the 4th is 81. And then our bases, well, those exponents must be the same. We're going to do the same thing over here, except this one's going to look kind of funky. 1/2 to the x equals 256. Well, a 1/2, that's the same as 2 to the negative 1, because there's a positive 1 on that 2 in the denominator. If I move it up, it becomes a negative exponent. Well, now I just have something that's a base 2. I can get 256 to base 2. I multiply my exponents there. And 256 is the same as 2 to the 8th power. Well, now again, same bases. Let's look at their exponents. Negative x must equal 8 divided by a negative 1. X equals negative 8. Hopefully this was helpful. If it was, please click that like button. If you want to see more videos like this, please subscribe to the channel, or at least look around, maybe click on some more of those videos. And if you have any questions, please leave those in the comments below. And have a great day, everybody.